Algebra 2, 8-1 notes, model inverse and joint variation. So when we are looking at inverse variation, we are relating x and y with a constant, and this time y is equal to a divided by x. And the other way we could write this is xy equals a. So if I took that y equals a over x, and I multiplied both sides by x, that's how I get that xy equals a. So sometimes it will be more useful to have it in this form, and sometimes we'll want it in that other form. It's just going to depend on the kind of problem. A is called our constant of variation. So just like if I had direct variation, y equals ax, that's direct. Maybe we should add that in as well. In that case, our constant of variation was a, and a was really like slope. So here I can have y equal a divided by x, and a is still a constant that's somehow relating those two. So for our first couple examples, we're just going to be looking at whether these are direct variation. Again, that's y equals ax. Whether they're inverse, y equals a divided by x, or if it's just neither. So I think most of the time, especially after you do a couple, you can look at this and really tell. But if the only foolproof method is to solve for y and see which form it's in. So again, if you can look at a right away and tell what form it's in, that's fantastic. But I went ahead and added 3x on both sides to solve for y equals 3x. So I have direct variation, and 3 is my constant of variation a, which is really just my slope. On the second one, to solve for a, I would have to solve for y, I'd have to multiply both sides by y, so that xy equals 3. And then I would divide by x. And so y equals 3 divided by x, and so I have inverse. So again, now that you've seen how this works, if you see a different one that has an x equal and the y in the denominator, you'll know that's inverse, but the first time it's kind of nice to solve it out. Last one, when I subtract x, y equals negative x, but I have plus 5. So because there is basically a y-intercept here, a y-intercept of 5 and a slope of negative 1, it will be neither. So for example 2, we're looking at these in table form. So when I'm looking at these in table form, I have my y's and my x's, but I don't know anything about my constant of variation. So I use a different method on these ones. So for direct, I know that I have the relationship y equals ax, and if I divide both sides by x, that means that y over x is going to equal that constant of variation. So if I take all my y's and I divide with the corresponding x's and I get a constant, then I have direct. If I look at inverse, we know that inverse is y equals a divided by x. And again, I'm solving for that constant of variation because I have x and y already. And I multiply both sides by x, then I have xy equals a. So if I can multiply my x and y together and get a constant, that's when I know that I have inverse. So we're just going to go through and try these. So first I'm going to do the fraction one. So y over x would be 2 over negative 6. Does that equal 4/3? No. So this is going to not be direct. So now we're going to check for inverse by multiplying them. So 2 times negative 6, that's going to be a negative 12. Negative 3 times 4, negative 12. 0 times 6, 0. 3 times 8, 24. We just know it's not going to work, don't we? So when I tried dividing them, I didn't get a constant. When I tried multiplying them, I didn't get a constant. So this one is going to be neither. So it was not direct, it was not inverse. And so my answer is neither. We'll try the same method on the second one. First, I'm going to check for direct. So I will look at the slope, y over x, and see if that's a constant. 2/10, does that equal 4/20? Yes, those both reduce to 1/5, so that's looking good so far. How about 6/30? That also equals 1/5. 8/40ths, 1 equals 1/5. 10/50ths equals 1/5. So when I used y over x, they were equal. And so if y over x equals a constant, that's going to be direct. So I have really figured out my slope. My slope is 1/5. So on the last one, I'm guessing right away it's going to be inverse. So let's go ahead and just check for inverse. So inverse would be multiply my x and y and get a constant. So this is inverse. Multiply your x, y, get a constant. So 12 times 1 equals 12. 2 times 6 equals 12. Looking good so far. 4 times 3 equals 12. 3 times 4 equals 12. So every time I multiply by x and y, I get a constant, and so this one will be inverse. And you could see on that first one, when we checked the first two parts in our table, it looked like it could be inverse. We had to keep going. So you're really going to have to check all of them. For example 2, we are told the variables x and y vary inversely. So as soon as they say vary inversely, we know y equals a over x. That's what they're telling us. And y equals 15 when x is 1/3. Write an equation that relates to x and y. Find y when x equals -10. So there's different ways to start this out. I usually start out exactly with y equals a over x. And that's because I don't memorize more than one formula. I know that using x, y equals a can be helpful, but ultimately I want to write an equation that relates x and y, and I want it to be y equals. Now I'm going to substitute what I have. So 15, a is the constant of variation that I don't know, and then x is 1/3. So if I am dividing by 1/3, then to cancel that, I would need to multiply both sides by 1/3. And so 1/3 times 15 is 5. So now we know that 5 equals a. That's the first thing that we needed to do. Then our second step is substituting a back in and writing an equation. So that means our equation is now going to be y equals 5 over x. So all I did was I took this original inverse variation equation, and I substituted 5 for a. So I solved for a, I substituted it back into the equation. Now I have an equation that relates x and y. That's what they're telling me. Then it says find y when x equals -10. So now y equals 5 divided by -10, and y equals -1/2. So there's really three parts of my answer. I solved for a, I substituted it back to write an equation, and then I found my new y value. All right, the dreaded word problem. The driving times between two specific locations varies inversely with driving speed. So let's think about what varies inversely means here. The driving times vary inversely with speed. So that means if I drive faster, it will take me less time. So that's what inversely really means. When you increase one, the other one decreases. The driving distance between Chicago and Minneapolis is about 400 miles. Write a model that gives the driving time in T hours between Chicago and Minneapolis as a function of average driving speed R in miles per hour. Okay, this is super loaded. So all I know is that when I am doing distance, rate, and time, I have D equals RT. And I know that my distance is 400. And then they're telling me to write a model that gives the driving time in T hours as a function of average speed R. So that means we're solving for T. So I want T in terms of R, which is really unusual because normally when we're working any kind of problem solving, we treat the T as more of our X. So it's kind of interesting to solve and have it be T equals. So I have T equals 400 divided by R. So I have T, and remember T is a function of R. So T equals 400 over R. And that just means when I plug in stuff for R, it changes my T. So now for part B, so let's remember this equation because I need it on the next page. 400 equals, maybe it's like this, T equals 400 over R. Pretty sure that's right. So now we're going to make a table showing the driving time for average driving speeds of 32, 40, 50, and 60. So these are going to be all of our different r's. So we're going to start with these, and then we're going to solve and figure out how much time it takes. So I'm going to make a table for r and t. And r is those values, 32, 40, 50, and 60. And now I'll solve for t. So for the first one, this would be 400 divided by 32. And that's going to give me about 12 and a half, 12.5. We'll just use decimals here. Next one, 400 divided by r, which is 40. So it'll be 10. So you can see as I'm driving faster, as my rate goes up, my time is going down. 400 divided by 50 would be 8. And then 400 divided by 60. So I'm just using this formula, 400 divided by my rate. That's all I'm doing. So 40 divided by 6 is 6.67, 6 2/3. So we kind of goofed. We maybe should have written 12 and a half here, kept it consistent. It bugs me to write 0.67 when I can write 2/3, because I know 2/3 of an hour is pretty easy to do, right? 2/3 of an hour is just 40 minutes. So it makes more sense to have fractions here. All right, we survived the word problem. So joint variation is when we have a quantity that varies directly with the product of two or more other quantities. So by quantity, it could be like y varies directly with the product of like x and z, for example. And so you're still going to have some kind of letter in here, like an a or something. But you can vary with more than one thing. So if I have something like z equals axy, that would be z varies directly with x and y. And they might say jointly or jointly and directly. So watch for this kind of language. So for 4, z varies jointly with x and y. So we know that that's going to mean directly. So that means z equals axy. We just did this. I should have picked different letters. Also, z equals 60. So now they're giving us information to solve for a when x is 4 and y is 5. So a times 4 times 5. So let's go ahead and solve for a again. So remember, our steps are always solve for a, substitute back. So we solve for a. Now we're going to substitute back and write an equation. So z equals 3xy. That's our second step. And then we're going to find z when x is 5 and y is 5. Sometimes they'll have this third step and sometimes they won't. Sometimes they just want you to write an equation. So let's see, 3 times 7 times 5. 3 times 7 is 21. Times 5 is going to be 105. All right. So for this example, we're just having some practice with this. It varies inversely. That's one where we're dividing. So r equals a divided by s. Varies jointly. So we know that's like directly. So z, and with more than one thing. So z equals a times x and the square root symbols like this. Ax square root of y. P varies inversely with the cube. So cube is going to be like third power. So inversely means it would be a divided by q to the third. Varies directly with the square of n. So that's n squared, and inversely with p. So inversely means this one's going to be in the denominator. Denominator. So m equals, my a would be in the numerator, the n squared is in the numerator because it's directly with these, and then, or directly with the n squared, and then it will be over p. Varies jointly, so that would be jointly directly with u and v. So z equals a u v, and inversely, so over, the square of W. So not square root, but square. So over W squared. So that just gives you, I'm going to move this just so you can read that last one better. But that gives you just an idea about how we would use these in a sentence. This is the end of our 8-1 notes.